Okay, so a very welcome to all of you students. So today we are going to start with differentiation JEE. But before that, we will revise whatever we have done in differentiation in standard 11th as well as in 12th standard. So let's begin with rules of differentiation. Please concentrate on my cursor. If u, v and w are differentiable functions of x and k and c are constants, then what does the first rule say? If y is equal to u plus minus v, then dy by dx is equal to du by dx plus or minus dv by dx. So the first rule is for the sum and the difference. Okay, now let's see the second rule. If y is equal to u into v, then dy by dx is equal to u into dv by dx plus v into du by dx. The second rule is called as the product rule. Third rule, if y is equal to c into u, where c is a constant, then dy by dx is equal to c into du by dx. Fourth rule is also the product rule. If y is equal to u into v into w, then dy by dx is equal to uv dw by dx plus vw du by dx plus uw dv by dx. Fifth rule is for quotient, division of two functions. If y is equal to u by v, then dy by dx is equal to v into du by dx minus u into dv by dx whole upon v square, where v should not be equal to 0. Sixth rule, if y is equal to k by v, then dy by dx is equal to minus k by v square into dv by dx. Then as you can see, we have the list of formulas of differentiation. On the left hand side are the functions and on the right hand side are their derivatives. Now we all know constant ka derivative is 0. Derivative of x raised to n is n into x raised to n minus 1. Derivative of root x is 1 by 2 root x. Derivative of sin x is cos x. Derivative of cos x is negative sin x. Derivative of tan x is sec square x. Derivative of cosec x is minus cosec x cot x. Derivative of sec x is sec x tan x. Derivative of cot x is negative cosec square x. Derivative of e raised to x is e raised to x. Derivative of a raised to x is a raised to x into log a. Derivative of log x is 1 by x. Derivative of log x to the base a is 1 by x log a. Derivative of x is 1. Derivative of 1 by x is minus 1 by x squared. So we are already familiar with this, all the list of formulas of derivatives. Then the seventh point, we have seen nothing but composite function, or it is also known as chain rule. So what does the chain rule says? If y is equal to f of u is a differentiable function of u and u is equal to gx is a differentiable function of x, then y is equal to f of g of x is a differentiable function of x and dy by dx is equal to dy by du into du by dx. Now recollect this composite function concept. We have done it in 12th standard theory lectures. These are the list of formulas which you are already familiar. On the left hand side, you can observe these are the functions, and on the right hand side are their derivatives. So this is the list of formulas. I will scroll down slowly. You just go through it once. I've obviously given you in writing already, and this PDF I have already sent to you. The students are requested to write down all these things in your notebook. Okay, now next we move on to 8th point, derivative formulas of inverse trigonometric functions. So on your screen, you can see the derivative of inverse trigonometric functions. D by dx of sine inverse of x is 1 by under root 1 minus x square. D by dx of cos inverse of x is negative 1 upon root 1 minus x square. Derivative of tan inverse of x, derivative of cot inverse of x, derivative of sec inverse of x, and derivative of cosec inverse of x. Just go through it once. We have done everything very properly. in the theory lectures. So we're just revising whatever we have done in 11th and 12th standard in theory lectures. So if you are visiting, if you are seeing this is the first lecture of JEE entrance, students are requested to watch the differentiation videos of standard 11th and 12th, and then you can see this video. Okay, the ninth one, derivative formulas for inverse composite trigonometric functions. So these are the formulas of inverse composite trigonometric functions: sine inverse fx, cos inverse fx, tan inverse fx, cot inverse fx, and all that. Please just go through it and just give your time. Next, we have seen in the theory lectures, the 10th point, we move on to derivative of, that is, logarithmic differentiation. When we have one function raised to another function, we are going to make use of this logarithmic differentiation, students. Then 11th one, we have seen differentiation of implicit function in the theory lectures. The function that is combining with x and y, such a functions are called as implicit function. Then the 12th one, we have seen differentiation of parametric functions. If x is equal to f of t, y is equal to g of t are the differentiable functions of parameter t, then y is a differentiable function of x, and dy by dx is equal to dy by dt upon dx by dt, where dx by dt should not be equal to 0. Now, it is not necessary that only t can be the parameter. Parameter can be theta, parameter can be alpha, parameter can be beta, parameter can keep on changing. Okay, 12th point, just go through it. Then the 13th one, we have seen differentiation of one function with respect to the other function. So what do we do? Fx and gx are the two functions of x. So we have to differentiate fx with respect to gx. So we take fx as u and we take gx as v. So therefore du by dv equals what? Du by dx upon dv by dx. This is, we have done under the section differentiation of one function with respect to the other function. Recollect theory lectures. Then the 14th point, we have seen the higher order derivative. 15th point, we have seen the nth order derivative. And the 16th point, we have seen differentiation of infinite series. So all these things, we have done it in detail in theory lectures. Okay, now moving on to properties of inverse function. This is again very important part of differentiation. We need properties of inverse functions for solving the problems that are dependent on inverse function, students, as you know that very well. The first one, sine inverse of sine x is x, as well as sine inverse of x is also equal to x. And similarly, it holds true for the remaining inverse function also. It is written similarly for other inverse function, we have the same. Okay. Second one, sine inverse of minus x is minus sine inverse of x. Tan inverse of minus x is minus tan inverse of x. Cos inverse of minus x is pi minus cos inverse of x. Then fifth property, sine inverse of 1 by x is equal to cosec inverse of x, or cosec inverse of 1 by x is equal to sine inverse of x. Property number 6, 7, 8, 9, you just go through it. We have done it everything in the theory lectures. We have used this property when we have done the inverse section part. Property of tan inverse, 8th one, you can observe tan inverse of x minus y upon 1 plus x into y equals tan inverse x minus tan inverse y. Property number 9. Then property number 10, 11, and 12, they are all pi by 2 properties. Sin inverse x plus cos inverse x is pi by 2. Tan inverse x plus cot inverse x is pi by 2. Sec inverse x plus cosec inverse x is pi by 2. Now, from the property number 13 onwards, like you remember, 13th one, Okay, before seeing the 13 property students, what we can do is we can just have a look on this important substitution. See point number 18 on your screen, important substitutions. Now, if we have 1 minus x square as the expression, then we either put x is equal to sine theta or we put x is equal to cos theta. Recollect, substitution method also we have done under inverse trigonometric function. Second expression, if we have the expression 1 plus x square, we are going to substitute x is equal to tan theta or x is equal to cot theta. And if we have the expression x square minus 1, so we are going to substitute x is equal to sec theta or x is equal to cosec theta. So first three substitutions are because of the fundamental identities. Okay. Then the fourth one, if we have the expression 2x into root 1 minus x square, then we put either x is equal to sine theta or x is equal to cos theta. If the expression is 2x upon 1 plus x square or the expression is 2x upon 1 minus x square, then we put x is equal to tan theta because it is the formula for sine to theta, and the other one is the formula for tan to theta. Because if we put x is equal to tan theta, so the first half, this is going to become 2 tan theta upon 1 plus tan square theta, so that equals nothing but sine to theta, and 2 tan theta upon 1 minus tan square theta becomes tan to theta. That is how it works. Sixth one, if the expression is 1 minus 2x square, we put x is equal to sine theta. Even the formula for that is nothing but cos to theta. The seventh point, if we have 2x square minus 1, then we put x is equal to cos theta. The formula for that is cos to theta. Then the eighth one, if the expression is 1 minus x square upon 1 plus x square, if we put x is equal to tan theta, this becomes the formula for again cos to theta, because 1 minus tan square theta upon 1 plus tan square theta, it is cos to theta. Then the ninth expression, if we have the expression 3x minus 4x cube, we put up x is equal to sine theta because it becomes the formula for sine 3 theta. 10th one, 4x cube minus 3x is the expression, we put x is equal to cos theta, students, because it is the formula for cos 3 theta. 11th one, if the expression is 3x minus x cube upon 1 minus 3x square, we put x is equal to tan theta. The formula is for tan 3 theta. Then 12, 13, 14, and 15, these are the substitutions that you need to remember. So if these are the expressions, we are going to use these substitutions which are written in front of them. So these 15 points which I have shown to you under point number 18, important substitutions, they are all to be remembered as it is, and obviously we have already used them in the theory lectures. Okay, now we come on to point number 13, students. Now under the point number 13, as you can observe, just 1 second, I'll try to highlight this. Give me a minute. Now, if you observe this, sine inverse of under root of 1 minus x square is nothing but equal to cos inverse of x, or else cos inverse of under root of 1 minus x square is nothing but equal to sine inverse of x, students. Now, why this happens? The reason for that is what? Now, if I put x is equal to, in the first one, sine inverse of under root of 1 minus x square, why this becomes cos inverse of x? The explanation for that. In this first one, as you can see my cursor, if I put in this under the root, if I put x is equal to cos theta, so if I put x is equal to cos theta, then under the root I'll be getting 1 minus cos square theta. 1 minus cos square theta is nothing but sine square theta, and under root of sine square theta becomes sine theta, and sine inverse of sine theta is theta. And what is theta? So theta is nothing but cos inverse of x. So students, what happens is over here, you need to remember that sine inverse of under root of 1 minus x square becomes nothing but equal to cos inverse of x. Okay. And similarly, if you have cos inverse of under root of 1 minus x square, it becomes nothing but equal to sine inverse of x. So this is the explanation for point number 13. So similarly, students, you can see point number 14 also, point number 15 also, and point number 13, 14 and 15, they are all because of the fundamental identity. We do those substitutions. Okay, then point number 16, you can observe sine inverse of 2x into under root of 1 minus x square, that equals nothing but equal to twice of sine inverse of x. Point number 17, you can observe sine inverse of 3x minus 4x cube equals 3 times of sine inverse of x. Okay, now as you can see, point number 17, I will try to explain you over here. Now for the 17th point, why does sine inverse of 3x minus 4x cube equals to 3 sine inverse of x? So as you can observe in this part, okay, just let me take a pen. Now in this part, 3x minus 4x cube, observe this expression. Whenever we have this expression 3x minus 4x cube, we substitute x is equal to sine theta. Okay, so I'll just show you where is that expression. I come back over here. You can see point number 9, see my cursor. When it is 3x minus 4x cube, we put x is equal to sine theta because it is the formula for sine 3 theta. So now I come back over here. So in point number 17, if I put x is equal to sine theta over here, so sine inverse remaining same, this is going to become sine 3 theta. And sine inverse of sine 3 theta is 3 theta, and theta gets replaced by sine inverse of x, and that is how it works. Sine inverse of 3x minus 4x cube is nothing but equal to 3 sine inverse of x. Similarly, point number 18, 19, 20, 21, 22, as well as, yeah, till 22, it's the same. We go by substitution and we get the inverse functions. So if you can remember these, it is well and good. Otherwise, we can solve this by using method of substitution also. याद रहेगा तो अच्छा है. Otherwise, you can put x is equal to sin theta और cos theta respectively, जो भी expressions होंगे उसके हिसाब से आप उसको solve भी कर सकते हो. If you can remember these, it will be more better. I have sent you the PDF. You are supposed to write down each and every point that I am sending. So important substitutions we have already seen. Then we have seen properties of inverse functions. Okay. Now you can see points to be remembered. Point number 19. You can see my cursor moving. Okay. So we have to remember all these points, like 1 plus cos 2x is nothing but equal to 2 cos square x. ये सारे formulas हैं. You can just go through it. 1. तो ये सारे formulas आप जितना याद रखोगे उतना better है. 9, the 10th one, everything. Then we are already familiar with point number 20, laws of logarithm. Laws and results दोनों हैं इसमें. So these are the 8 points under point number 20, which we need to remember. Laws of logarithm important है. ठीक है. Now important shortcuts, point number 21. Now for explaining important shortcuts, I will use the board because it will be better to understand on the board than to explain you directly in this PDF way. Okay. So just give me a minute. We'll switch on to the board. Okay, students. Now, as we have discussed, so let us see some important shortcuts and the time-saving results. So please write down important shortcuts and the time-saving results. Under this, the first one, write down if y is equal to u raised to v, then dy by dx equals, write down u raised to v bracket v by u into u dash plus log u into v dash, and close the bracket. Don't worry, write down. I will explain with the help of examples. This is the first important shortcut. Out of the all, this is the first one. So where what we have to remember, students, where u is also a function of x and v is also a function of x. मतलब अगर एक पावर के फंक्शन में दूसरा पावर है तो रिकलेक्ट हम थियरी लेक्चर्स में क्या करते थे, वी वर टेकिंग लॉग ऑन बोथ द साइड्स ऑफ इक्वालिटी एंड देन वी वर मेकिंग यूज ऑफ लॉगरिथमिक डिफरेंशिएशन. अभी लॉगरिथमिक डिफरेंशिएशन हम नहीं यूज करेंगे. So if you are having y is equal to u raised to v, where u is also a function of x and v is also a function of x, then what will happen is that, as you can see, just better, I'll use my pointer. Then dy by dx is equal to u raised to v bracket v by u into u dash plus log u into v dash होगा. U dash means derivative of u with respect to x and v dash means derivative of v with respect to x. So chalo, please note down the first time saving result, or you can say the shortcut. Now let us see the example for this. एक example ले लेते हैं यहाँ पे. No doubt जब हम problem start करेंगे then we will be doing the problems, but अभी एक एक example ले लेता हूँ मैं हर एक के लिए. So write down example. Now suppose if it is given to me y is equal to, एक ऐसा ले लेते हैं function sin x to the power log x. Function raised to function है. So therefore dy by dx अगर हमें find करना है तो ये rule और ये time saving result हम apply करेंगे students. So if you observe, if you compare y is equal to u raised to v and sin x raised to log x, so over here sin x is u and log x is v. ऐसा मार्क कर लो आप आपके रेफरेंस के लिए. अब हम क्या करेंगे, u is sin x, v is log x. ये u और v हम यहाँ पे सब्स्टिट्यूट करेंगे. So therefore dy by dx is equal to what? U raised to v. So sin x raised to log x, देखो this will be equal to sin x to the power log x bracket v by u. So log x by sin x. Write down log x by sin x into u dash. U dash means what? Derivative of u with respect to x. So u क्या है students? U is sin x. So sin x का derivative is nothing but cos x plus log u. So it will be nothing but log of sin x into v dash. तो यहाँ पे v क्या है? log x है. log x का derivative is nothing but 1 by x. Close the bracket. At the maximum इसको हम rearrange कर सकते हैं. So therefore our dy by dx is nothing but sin x to the power log x bracket cos x by sin x is nothing but cot x. तो ये ऐसा हो जाएगा cot x into log x plus this will be written as log of sin x whole upon x. Close the bracket. ऐसा हो जाएगा ये. So this is our final answer and nothing but our dy by dx. तो देखो कितना simple procedure है. Instead of using logarithmic differentiation, which we have done it in theory lectures, we just apply this time saving result and how effortlessly we have done this example. Okay, please make a note of this. Then we'll move on to the second time saving result. So students, now let us move on to the second time saving result, or you can say the second shortcut. Write down the second one. अच्छा, अब ये जो shortcut है, ये जो time saving result है, this is only applicable for implicit functions. Write down. ऐसा heading लिखो, implicit functions. नाउ रिकलेक्ट इम्प्लिसिट फंक्शंस में हम थियरी लेक्चर्स में क्या करते थे? एन इक्वेशन वाज गिवन टू अस, we were considering that equation, we were differentiating with respect to x, we were collecting all the dy by dx terms together on one side and non dy by dx terms to the another side of equality. तो dy by dx कॉमन लेके हम उसको क्रॉस मल्टीप्लाई करते थे. ये प्रोसीजर हम थियरी लेक्चर्स में फॉलो करते थे, बट द सेम प्रोसीजर नॉट टू बी फॉलोड फॉर एंट्रेंस एग्जाम. अभी मैं आपको एक एकदम इजी वाला शॉर्टकट सिखाने वाला हूँ, so please pay attention completely on the board. So please write down over here, for implicit function, if we want to find out dy by dx, अगर फाइंड करना है तो इट इज गिवन बाय माइनस डेल एक्स अपॉन डेल वाई. ऐसा लिखो आप. हाँ देखो डेल कैसा लिखते हैं, इट इज रिटर्न दिस वे, ऐसा डेल इज रिटर्न दिस वे, डेल. ठीक है, so write down dy by dx is equal to minus del x by del y. Okay, now ये जो concept है, now in higher standard you are going to learn one of the concept that is called as partial differentiation. अब वो partial differentiation का concept is not there in the so students, since partial differentiation का जो concept है was not there in 11th and 12th standard, so you are requested to please pay attention. So example भी लेंगे हम. Now dy by dx is equal to what? So it is minus del x by del y. So just write down for your reference, start writing down. एक concept है that is called as, लिखो आप, partial differentiation. Now what does this del x means? वो आप लिख लो, del x. So del x means differentiate, ऐसा लिखो, del x means differentiate the function, differentiate the function with respect to x, keeping y constant. ऐसा लिखो आप. Del x means what? Differentiating the function with respect to x, keeping y constant. y को हमें constant मानना है. और फिर लिखो नेक्स्ट लाइन पे del y. So del y means what students? So differentiating the function with respect to y, keeping x constant. अब ये रूल है, अब ये रूल किसका है? पार्शियल डिफरेंशिएशन. एज यू कैन सी द नेम इटसेल्फ इज पार्शियल. पार्शियल मींस हाफ, पार्शियल डिफरेंशिएशन. ठीक है, तो dy by dx कैसे मिलेगा अभी हमें इम्प्लिसिट फंक्शन का? तो इट विल बी माइनस del x by del y. Del x means what? Differentiate the function with respect to x, keeping y constant, and del y means differentiating the function with respect to y, keeping x constant. अभी एक एग्जांपल ले लेते हैं, बट उसके पहले आप ये नोट डाउन कर लो for your reference. Okay, so now let us take down one example where I will explain you this partial differentiation का concept. So write down example. X cube plus y cube is equal to 3axy. Then find dy by dx. Find dy by dx. Solution for the problem. अब ये देखो implicit function है students, that is combination of x and y वाला problem है. So let us first consider, ऐसा देखो, consider write down this equation, x cube plus y cube minus 3axy is equal to 0. So whenever we are having an implicit function, we will bring all the terms to one side. तो ये 3axy हमने left hand side पे लेके आ गया. This is equal to 0. Now what we are supposed to do, we are supposed to use partial differentiation का concept. So please pay attention for 5 to 7 minutes. Let me write and explain, and then you can write down for your reference. ठीक है? अब देखो शॉर्टकट क्या बोलता है स्टूडेंट्स, दैट dy by dx कैसे मिलेगा, तो इट इज नथिंग बट माइनस del x upon del y. So therefore from here now we are supposed to find out what, pay attention. So dy by dx will be equal to minus sign. तो सबसे पहले स्टूडेंट हमें फाइंड करना है del x. Okay, now what I'll do, I'll just bifurcate this. Now give me time to write and explain very properly. अब सबसे पहले स्टूडेंट्स हमें फाइंड करना है del x. तो ऐसा लिखेंगे हम for del x. दो चीजें करिए, एक del x करना है और फिर del y करना है. Now del x means what? Differentiate the function with respect to x keeping y constant. So what is the function? This is the function, students. We are supposed to differentiate this function with respect to x. So just observe del x का working कैसे होगा, d by dx of what, x cube plus y cube minus 3axy equal to 0. इसका डेरिवेटिव लेना है. अभी इक्वल टू 0 लिख के मतलब नहीं है, बिकॉज दिस इज ओनली द फंक्शन. यही लेफ्ट हैंड साइड का डेरिवेटिव लेना है. राइट हैंड साइड इज ऑलरेडी 0, so that we don't need it over here. Equal to 0 नहीं चाहिए, so we don't include that equal to 0. We are supposed to find out derivative of this function with respect to x. But what is important, with respect to x करना है keeping y constant. y को हम constant assume करने वाले हैं. So just observe what will this become, students. d by dx of x cube, we all know that is nothing but 3x square. d by dx of y cube is nothing but 0. y को हमें constant assume करना है. मैं नहीं बोल रहा हूं, ऐसा रूल बोल रहा है. पार्शियल डिफरेंशिएशन का कंसेप्ट बोल रहा है कीपिंग y constant. So d by dx of y cube will be 0 minus over here 3ay constant है, and x का derivative with respect to x is nothing but 1. So students, what will this become? This will become 3x square minus 3ay. ठीक है, तो ये जो फंक्शन था, we have differentiated this function with respect to x keeping y constant. So this is nothing but our del x. Now what I'll do, ये जो del x हमने find किया ना, अब ये del x मैं यहाँ पे न्यूमरेटर में लिखूंगा. ठीक है, so just observe students, do not write down still. Now what is del x? So it is nothing but 3x square minus 3ay and the bracket closes. Now what am I supposed to do? I am supposed to find out del y. Now but before I find out del y, एक चीज मैं आपको क्लियर कर देता हूं यहाँ पे. For over here d by dx of y cube. Now recollect, in the theory lectures we have already done that if we are having d by dx of y cube, ताकि ये कंफ्यूजन आपको माइंड में नहीं रहे, इसलिए ये मैं पहले समझा देता हूँ, फिर del y फाइंड करेंगे. d by dx of y cube थियरी लेक्चर्स में हमने इसके ऊपर चेन रूल अप्लाई करके y cube का डेरिवेटिव वी हैव रिटर्न 3y square into dy by dx, है ना. d by dx of y cube हम ऐसे लिखते थे. फिर आप बोलोगे कि सर d by dx of y cube तो ये होना चाहिए, तो करेक्ट है, बाय चेन रूल ये बिल्कुल सही है. बट यहाँ पे हम चेन रूल अप्लाई नहीं कर रहे हैं. वी आर अप्लाइंग द कंसेप्ट ऑफ partial differentiation. Partial differentiation says what? When I am finding out del x, see over here, when I am finding out del x, I am supposed to differentiate the function with respect to x, but keeping y constant. y को मेरे को constant assume करना है यहाँ पे. तो डी बाई डी एक्स ऑफ वाई क्यूब कांस्टेंट है एंड कांस्टेंट का डेरिवेटिव 0 होता है। गलती से भी डी बाई डी एक्स ऑफ वाई क्यूब 3y² dy बाई dx आपको नहीं लिखना है पार्शियल डिफरेंशिएशन करते वक्त, एंड पार्शियल डिफरेंशिएशन इज ओनली इन एंट्रेंस, वी डोंट हैव इट इन आवर थियरी लेक्चर्स। तो थियरी लेक्चर में हम सही जा रहे थे, ये परफेक्ट है फॉर थियरी लेक्चर्स, और एंट्रेंस के भी लेक्चर के लिए सही है, बट व्हेन वी आर डूइंग पार्शियल डिफरेंशिएशन डी बाई डी एक्स ऑफ वाई क्यूब इज 0। तो ये चीज आपको याद रखनी है। ओके ये लिखने की जरूरत नहीं है, दिस इज फॉर योर रेफरेंस। अभी हमने डेल एक्स फाइंड कर लिया ना, अभी हम डेल वाई फाइंड करेंगे। ओके so please give me a minute, I'll explain that also. Now after this thing, ये होने के बाद थोड़ा मैं यहाँ पे बाइफरकेट कर देता हूँ इसको। अभी मैं डेल वाई का वर्किंग करूंगा, so please do observe what is going to happen now. So now for del y, now let's see what will happen for del y. सबसे पहले देखते हैं क्या बोलता है वो। डिफरेंशिएटिंग फंक्शन विथ रिस्पेक्ट टू y कीपिंग x एज कांस्टेंट। अभी x को कांस्टेंट एज्यूम करना है हमें जब हम del y फाइंड करेंगे। तो वंस अगेन प्लीज पे अटेंशन। नाउ व्हाट वी आर सपोज टू डू, वी आर सपोज टू डिफरेंशिएट विथ रिस्पेक्ट टू y। तो x क्यूब प्लस वाई क्यूब माइनस 3axy का डेरिवेटिव हमें फाइंड करना है, बट विथ रिस्पेक्ट टू y फाइंड करना है, और x को हमें कांस्टेंट एज्यूम करना है। तो दिस विल बी इक्वल टू डी बाई डी वाई ऑफ एक्स क्यूब। तो एक्स क्यूब का डेरिवेटिव 0 हो जाएगा, y से डिफरेंशिएट कर रहे हैं, x को कांस्टेंट एज्यूम करना है, प्लस वाई क्यूब का डेरिवेटिव विल बी नथिंग बट 3y² माइनस ओवर हियर 3ax कांस्टेंट है, y का डेरिवेटिव विथ रिस्पेक्ट टू y इज नथिंग बट 1 स्टूडेंट। So this is further nothing but equal to what? तो ये क्या हो जाएगा 3y² माइनस 3ax। तो ये हमें क्या मिल गया, we have obtained this del y। तो लिखो del y कहाँ पे लिखना है, del y डिनोमिनेटर में होना चाहिए। So write down what is del y का वर्किंग, so it is nothing but 3y² minus 3ax and close the bracket. Please make a note, अभी आप लिख लो ये पूरा चीज अलॉन्ग विद दिस। वैसे तो एग्जाम में सिर्फ इतना ही लिखना है, बट सिंस इट इज जस्ट एन एक्सप्लेनेशन पार्ट, तो मैंने प्रॉपरली आपको डेल एक्स भी अलग से सॉल्व करके बता दिया और डेल वाई भी आपको अलग से सॉल्व करके बता दिया। दिस वर्किंग शुड नॉट बी रिटर्न व्हेन वी आर सॉल्विंग द एग्जाम्पल, ये सिर्फ आपके रेफरेंस के लिए। आप डायरेक्ट ऐसा भी लिखोगे तो भी चलेगा, इनफैक्ट ऐसा ही लिखना है हमें जब हम एग्जाम्पल सॉल्व करेंगे, बट आई हैव गिवन यू द डिटेल्ड एक्सप्लेनेशन, प्लीज मेक अ नोट ऑफ दिस। So these two are the very important shortcuts in differentiation so far as differentiation is concerned, और ये implicit function के लिए एकदम perfect shortcut है। Okay, so whenever it's an implicit function, dy by dx is minus del x by del y, and this concept is called as partial differentiation. Del x means differentiate the function with respect to x keeping y constant, and del y means differentiate the function with respect to y keeping x constant. I have shown you the working of this. अभी obviously हम इसमें क्या कर सकते हैं, we can take 3 common and we can cancel that out, इतना ही कर सकते हैं। तो चलो वो भी कंप्लीट कर लेते हैं, बट उसके पहले आप लिख लो। So what I do is I just rub off this working of del x and del y, और फाइनल आंसर यहाँ पे 3 कॉमन ले लो और वो कैंसिल हो जाएगा। ठीक है, तो चलो let us begin. So just give me a minute to rub off this part. By that time you can take 3 common in the numerator as well as in the denominator. Okay, so therefore what will we get, students? So therefore dy by dx is further equal to, okay, minus sign remaining same, 3 common आ जाएगा, so we will be left out with x² minus ay in the numerator and y² minus ex in the denominator with this minus sign remains. 3 कॉमन आ गया और 3 कॉमन आके कैंसिल भी हो गया, हर एक स्टेप शो करने की जरूरत नहीं, हमें ये आंसर मिल गया. अच्छा, अभी ऐसा हो सकता है ऑप्शंस में, now this minus sign can be taken inside, so dy by dx can be also written as ay minus x square upon y square minus ex. तो ऑप्शन ऐसा भी हो सकता है. जब हम प्रॉब्लम सॉल्व करेंगे, जब हमारे सामने ऑप्शंस रहेंगे, ऑप्शंस कैन बी इन दिस मैनर आल्सो और ऑप्शन कैन बी इन दिस मैनर आल्सो. कोई भी रहे फर्क नहीं पड़ता है, हमें सही आंसर मार्क करना है. ओके, बट दे बोथ आर सेम, दे हैव सेम मीनिंग. ओके, प्लीज मेक अ नोट ऑफ दिस. So students, let us see some more time-saving results. I have already written them on the board, and now we will see their examples. अभी फर्स्ट वाला देखो, टाइम सेविंग रिजल्ट क्या बोलता है. इफ f of, अगर ऐसा फॉर्मेट है, f of x raised to m plus minus y raised to m upon x raised to m minus plus y raised to m equal to some constant, then dy by dx is always equal to y by x. तो थर्ड वाले का पहले एग्जांपल देख लेते हैं. Write down example. So first you write down this third one and then the example. Okay. Now for the third one, S stands for any function. Say for example, अगर यहाँ पे दिया है sin inverse of x square plus y square upon x square minus y square equal to log 10 दिया है, then dy by dx is always equal to y by x ही आएगा. f फंक्शन के जगह पे साइन इनवर्स एंड कांस्टेंट के जगह पे कांस्टेंट तो कुछ भी हो सकता है. so this is nothing but log 10, then dy by dx is always equal to y by x. now recollect student, ये थियरी लेक्चर में हम इसको कैसे सॉल्व करते थे. we were taking sin inverse over there, this comes under implicit function only, so we were taking sin inverse over there. तो ये क्या हो जाता था, x square plus y square upon x square minus y square is equal to sin log 10. then we were differentiating और फिर इसको हमें u by v rule अप्लाई करना पड़ता था. then rearranging dy by dx terms together and all that, फिर हमें dy by dx is equal to y by x मिलता था. बट अभी एंट्रेंस में अगर ऐसा प्रॉब्लम दिखा तो we need not to solve this, the dy by dx will be always equal to y by x. Please note down this example. अच्छा, not only dy by dx will be y by x and also अगर dy by dx y by x है तो d2 y by dx2 will be also equal to 0. ये और एक पॉइंट आप ऐड कर दो इसमें कि अगर dy by dx y by x आया तो जो इसका सेकेंड ऑर्डर डेरिवेटिव है d2 y by dx2 0 आएगा. ओके, नोट डाउन दिस. Now to explain, अच्छा, as I said, यहाँ पे जरूरी नहीं है कि साइन इनवर्स फंक्शन ही होना चाहिए. एनी इनवर्स फंक्शन, साइन इनवर्स, कॉस इनवर्स, टैन इनवर्स, कॉट इनवर्स, सेक इनवर्स, कोसेक इनवर्स, कोई भी फंक्शन रहने दो, यहाँ पे कोई भी कांस्टेंट रहने दो, आंसर वही आएगा. से फॉर एग्जांपल, इंस्टेड ऑफ साइन इनवर्स, ओके, नाउ इंस्टेड ऑफ साइन इनवर्स में यहाँ पे ऐसा फंक्शन लिख देता हूँ. यहाँ पे मैं लिखता हूँ tan ऑफ x square plus y square upon x square minus y square equal to say e raised to a. now e raised to a तो कांस्टेंट है, x का फंक्शन नहीं है, तो स्टिल इसका जो आंसर है dy by dx will be y by x and d2 y by dx2 will be equal to 0 ही रहेगा. अच्छा, जरूरी नहीं कि पावर 2 ही होना चाहिए, पावर 3 भी हो सकता है, पावर 1 भी हो सकता है. ठीक है, यहाँ पे पावर कुछ भी हो सकता है, तो पॉजिटिव पावर की बात कर रहे हैं. अच्छा, वन मोर कॉम्बिनेशन, ऊपर प्लस है तो नीचे माइनस, ऊपर माइनस है तो नीचे प्लस. आई एम मेकिंग द चेंजेस इन द एग्जांपल्स आई एम टेलिंग यू. तो ये सेकंड एग्जांपल नोट डाउन कर लो पहले. फर्स्ट एग्जांपल साइन इनवर्स वाला था, ये सेकंड एग्जांपल हो गया dy by dx y by x और d2 y by dx2 0 मिलता है. और एक एग्जांपल चेंज करके बता देता हूँ आपको. ठीक है, नाउ व्हाट कैन हैपन, इंस्टेड ऑफ x स्क्वायर this can be x cube. ये पावर क्यूब पावर 3 हो सकता है, एंड एट द सेम टाइम ऊपर माइनस और नीचे प्लस हो सकता है, एंड इंस्टेड ऑफ tan फंक्शन सपोज इफ आई राइट डाउन दिस एज कोसेक इनवर्स लिख दो यहाँ पे, और यहाँ पे एनी कांस्टेंट से मे बी इक्वल टू सिर्फ, चलो सी नहीं लिखता हूँ मैं, से मे बी 10 लिख दिया, चलो ठीक है। तो स्टिल इसका जो आंसर है ना स्टूडेंट, dy बाई डी एक्स वाई बाई एक्स ही मिलेगा, एंड डी टू वाई बाई डी एक्स टू हमेशा 0 ही रहेगा। प्लीज नोट डाउन, देन विल मूव ऑन टू द नेक्स्ट एग्जाम्पल, मतलब नेक्स्ट शॉर्टकट टाइम सेविंग रिजल्ट। अभी फोर्थ वाला देखो व्हाट इट सेज, इफ x रेज टू m इंटू y रेज टू n इज इक्वल टू x प्लस वाई रेज टू m प्लस n, देन dy बाई डी एक्स इज y बाई x एंड डी टू वाई बाई डी एक्स टू 0 होता है। अच्छा, इन द थियरी लेक्चर्स विच आई हैव टॉट, इसमें हमने लोगारिथमिक डिफरेंशिएशन से ये dy बाई डी एक्स y बाई x प्रूफ किया हुआ है, वी हैव ऑलरेडी डन दैट। तो नाउ अभी इसका एग्जांपल कैसे आएगा देखो यहाँ पे, राइट डाउन along with me. So if we are having, say for example, x raised to 4 into y raised to 5 is equal to x plus y raised to 9 is given, then obviously it's clearly visible students that dy by dx will be always equal to y by x, and the second order derivative d2y by dx2 will be always equal to 0. कैसे होना चाहिए, 4 प्लस 5 एम एन, तो ये m प्लस एन यहाँ पे होना चाहिए, एंड एज वी नो 4 प्लस 5 9 होता है, तो ये dy बाई डी एक्स वाई बाई एक्स मिलेगा, एंड सेकेंड ऑर्डर डेरिवेटिव विल बी 0। प्लीज नोट डाउन। ठीक है, देन नेक्स्ट टाइम सेविंग रिजल्ट इज फॉर इनफाइनाइट सीरीज। ये वाला भी एग्जांपल हमने थियरी लेक्चर्स में किया हुआ है। Now let's take example on this. Okay, let me tell you what is this. Y is equal to under root of fx plus under root of fx, अगर ऐसा infinity तक है, then dy by dx is equal to what? It is equal to f dash of x upon 2y minus 1 होता है। Let's understand by taking down one or two examples. तो लिखो example, if y is equal to अभी under the root, okay. Now suppose under the root the function is cos x plus under root of cos x plus under root of cos x, ऐसा चलेगा infinity तक। Then what should be dy by dx, तो लिखो then dy by dx will be equal to, now let us compare student, fx जो भी फंक्शन यहाँ पे है, तो dy by dx will be f dash of x upon 2y minus 1, तो ये जो upon 2y minus 1 है तो वो तो सेम रहेगा, upon 2y minus 1 चेंज नहीं होने वाला है। जो फंक्शन है उसका डेरिवेटिव न्यूमरेटर में लिखना है, वेरी सिंपल टू अंडरस्टैंड। व्हाट इज द फंक्शन, फंक्शन इज cos x, एंड वी ऑल नो स्टूडेंट्स cos x का डेरिवेटिव इज नथिंग बट माइनस sin x, दैट्स इट, हो गया। तो f dash of dy by dx is nothing but f dash of x, so cos x का derivative is nothing but minus sin x upon 2y minus 1. That's it. Problem is over. Note down this example, then we'll take one more example for your reference. लिख लीजिए आप नोटबुक में। थियरी लेक्चर्स में हम इसको कैसे करते थे, we were squaring on both the sides, स्क्वेयरिंग करके इसको किया था हम, बट अभी ऐसा करने की जरूरत नहीं, ये शॉर्टकट हम अप्लाई कर सकते हैं। Okay, now instead of this cos x, okay, I'll make the change in the same, so just give me 30 seconds का टाइम, इसको मैं रब कर देता हूँ। अभी सपोज यहाँ पे log x दे दिया, if the logarithmic function is given, यहाँ पे सब जगह पे log x आ जाएगा, then what will be dy by dx, तो अभी fx function is nothing but log x, एंड ऊपर क्या चाहिए हमें, f dash of x, तो log x का डेरिवेटिव, तो स्टूडेंट्स दैट इज नथिंग बट 1 by x, so what is the answer, 1 by x into 2y minus 1, ये हमारा dy by dx हो जाएगा, वेरी सिंपल। If you want, note down this example also. ये भी example लिख लो आप आपके reference के लिए. Next and the last one, sixth example. Y is equal to fx raised to fx infinity तक का. ये infinite series के लिए है. This is not for finite. This is for infinite. So then dy by dx will be equal to what? Y square upon 1 minus y into log fx into f dash x upon f dash of x upon fx. ऐसा याद रखना है हमें इसको. Okay. So चलो, let us take down example for the sixth one. So if y is equal to, now let us take any function, log x ले लो, sin x ले लो, चलो tan x ले लेते हैं. Tan x to the power tan x to the power tan x ऐसा कंटिन्यू होगा इंफिनिटी तक. Then students, dy by dx will be equal to what? So dy by dx will be equal to, न्यूमरेटर में y स्क्वायर आएगा, डिनोमिनेटर में 1 माइनस y इंटू लॉग fx. अभी आप कंपेयर करो, प्रॉब्लम में fx के जगह पे tan x है, तो यहाँ पे ये जो टाइम सेविंग रिजल्ट है, यहाँ पे जहां पे भी fx है वहां पे आप tan x डाल दो. So what is this going to become? This is going to become log of tan x into f dash of x. So tan x का derivative is nothing but sec square x upon tan x, and this itself is the final answer and dy by dx. अब अगर ऑप्शन में सिंप्लीफाइड फॉर्म में दिया है, साइन कॉस के फॉर्म में दिया है, तो सिंप्लीफिकेशन कैन बी डन अकॉर्डिंग टू द ऑप्शंस. बट अभी मैं फिलहाल इसको सिंप्लीफाई नहीं कर रहा हूँ. आई एम जस्ट कीपिंग माय dy by dx एज इट इज. प्लीज नोट डाउन. यहाँ पे भी कोई भी फंक्शन हो सकता है, जरूरी नहीं tan x ही होना चाहिए. एक्सपोनेंशियल फंक्शन, लॉगरिथमिक फंक्शन, ट्रिग्नोमेट्रिक फंक्शन, इनवर्स ट्रिग्नोमेट्रिक फंक्शन, tan इनवर्स ऑफ x भी हो सकता है. एनीथिंग ट्रू फॉर बोथ ऑफ देम. प्लीज मेक अ नोट. कोई भी फंक्शन हो सकता है दोनों में. So with this students, we have seen total 6 important time saving results today. So along with the synopsis, we have to remember this also. हर एक चीज हमें पता होनी चाहिए. We should be knowing the rules of differentiation, the derivative के formulas, composite function का concept. जितना भी differentiation हमने सीखा है 11th plus 12th standard में, वो पूरा by heart होना चाहिए. Should be perfectly known to us. Along with that, we should know these 6 time saving results which are going to play a very important role in the problem solving. So next time when we meet students, we will start solving the problems of differentiation. इसके ऊपर हम examples लेने वाले हैं, जितना भी synopsis हमने देखा हुआ है. Okay, so please note down this first, then we'll stop. Okay, so please keep studying and please keep watching my YouTube channel. Thank you very much.